We want to explore going from the rectangular to the polar coordinates. The rectangular coordinates are given in terms of x and y. In this picture I can see that this side is 4 lengths, length 4, and this side is also of length 4. So the rectangular coordinate would be simply 4, 4. To go to polar coordinates, what I need to do is find a radius, and I need to find an angle. To find the radius of this one, we simply use the Pythagorean theorem. The radius is equal to 4 squared plus 4 squared, which is going to be 4 radical 2. The angle between those, since it's an isosceles, I can use the arc tangent. The arc tangent of the opposite side to the adjacent side turns out to be pi fourths. Hence, when I look at this, we can take the rectangular coordinates, which would be 4, 4, and I can transform them to the rectangular or the polar coordinates, which would be 4 square roots of 2 and pi fourths. Okay, that was pretty simple to do. Just use Pythagorean theorem and the arc tangent. Let's see what it looks like going the other way. So in this case, let's say this side is 2, and the angle between them right here is going to be pi thirds. And what I want to do is find the x and y components. Okay, the x component here and the y component. The x component with respect to the angle is the adjacent side, and then of course I have the hypotenuse. So that if I take the cosine of pi thirds, this would be the ratio of the adjacent side to the hypotenuse. Or if I just solve for x, this would be 2 cosine of pi thirds. Cosine of pi thirds is 1/2, so this actually just turns out to be 1. All right, let's do the other one. If I take the sine, which is the opposite side, y over the hypotenuse, and if I solve for y, this is going to be 2 sine of pi thirds. The sine of pi thirds is radical 3 over 2. So I just get radical 3. Hence I can see that my my rectangular coordinates in this case are going to be 1 and square root of 3, whereas the polar coordinates, what I started with, would be the radius 2 and the angle, which would be pi thirds. Okay, so we've gone from the rectangular to the polar and from the polar to the rectangular, and you can see that's a pretty easy operation. But sometimes it gets a little more challenging when the numbers are a little nastier. So what we want to do is to explore this with our calculators. We want to do this one on the TI-36X Pro. This is just an emulator, but it does the same thing on the calculator. We're going to take this from our polar coordinates, and we want to change them to rectangular coordinates. So to do that, we go to Math. Over here where it talks about polar to rectangular or rectangular to polar, and we're going to put in our polar coordinates, and then we're going to change them to rectangular. So we select the first option. This particular one we're working with is negative 1.6, comma, and negative 1.5. All right, let's discuss what we have here, because these are polar coordinates. That negative 1.6 is the radius, but notice it's negative, which means that it goes exactly pi radians away from where we think it's going to be. That's what the negative does. So our radius is still going to be 1.6, but it's headed in the opposite direction. And then the negative 1.5, that's our angle in radians. Note that pi is 3.14 radians, so this is negative 1.5. Yep, it gets to be kind of confusing, which is nice that we can use the calculator. So once we put that in, we get a value that looks like this. This is just for the x coordinate alone. We still have to go get the y coordinate. So if I go math, over here to my rectangular to polar, and we want to change from the polar to the rectangular y coordinate, and we have to type this in again. I try to find some ways that I could do this out without retyping, or if I could copy. It doesn't seem to want to do this on this calculator, so we just put it all back in, just as we did. Okay, so this gives us the y coordinate. Now it may ask you to go ahead and round to 2 decimal places, and you can see that, but I find it easier if I just go into my mode, come over here to float, and say I want to round to 2 decimal places. Once I select that, I can go back up here to my answers, press enter, and it'll round it. There's my x coordinate, and here's my y coordinate. Okay. So I can go ahead and record that as the point negative 0.11 for the x and 1.60 for the y. All right, now let's go the other way. This time we want to change our rectangular coordinates to polar coordinates. So we go back to the same place. Here's our rectangular coordinate, which is going to be -2, comma, and -19. Okay, what this does is it uses the Pythagorean theorem to go ahead and find that radius. That's what we get from this one. Now we need to go find the angle, but we're given the parameters that it has to be from 0 to 2 pi. So we'll take a look at that. Here we want to go from my rectangular coordinates and get my angle. -2 and -19. All right, now this is in radians, which throws us off just a little bit. So this is -1.68 radians. Again, for reference, pi is 3.14, right? But they want this to go from 0 to 2 pi, and although this is coterminal with where we want to be at, it isn't within the domain that we want. So what we need to do is simply add 2 pi. And what this will do is it'll make it positive so that we can see where this is at. I've already got this rounded to 2 decimal places, so I can write down my answer then as 19.10 for the radius and 4.61 as going to be the angle. We want to do something very similar here, this time with the TI-84 CE. We're going to take our polar coordinates and change them to rectangular coordinates. But before I do that, I want to fix. You can see here I've got my fix too because I have to round to 2 decimal places, so I've gone ahead and put it into this one. All right, so then I'll get my answers where I want them. Well, to put in the polar coordinates, we come down to second, angle. You can see down below here in options 5 through 8, very, very similar to what we saw in the TI-36X Pro. So I'm going to change my polar coordinates to rectangular coordinates. And we'll put in 0.5, comma, and -5.5. Okay, there's our x coordinate. Now I go back and get my y coordinate, second, angle, and I want to get my polar form and change it to the y. Now this one is a little different than the 36. I can go actually and copy this if I want to, because I don't want to type all that in, and just delete that command, and it'll actually copy the measurements for the radius and theta. You can see they're both 0.35. That is correct. The x and y coordinates are equal at this particular place. All right, let's go the other way. This time let's go ahead and go from the rectangular to the polar. We'll put in -4, comma, and -13. And there is the radius. Now we go get the angle. Second angle. And I could cursor up there and copy that like I did before, but this one's probably just as easy to type it in since there's no decimals in there. Okay, there's my angle. Again, we're given the parameters that it has to be from 0 to 2 pi, and this is giving us a negative angle. So all I do is simply add 2 pi. And when I do, this gives me the positive angle that I'm looking for. Okay, we want to do a similar sort of thing, this time with the TI-nspire CX II. We have cast turned off, since this is what would happen in a normal testing situation. What I want to do is convert my polar coordinates to rectangular coordinates. So first off, let's go over here and set up a scratch pad. And I'm going to put in my coordinates. Here is 2.2 and 5.2. Now, here's what happens with the nspire. They think of these as complex numbers, and what this does is represent the radius and the angle. So rather than put in the comma, I have to tell the nspire that it's actually an angle. To do that, I come to Control, and then this book-looking thing right here, and this is the symbol for angle. Okay. Now it recognizes it as 2.2 is the radius, and the angle is 5.2. Let's come to the end here. Then I go Menu, Number, come down to Complex Tools, and remember I'm converting from polar to rectangular. Now this is going to look a little bit weird because the nspire thinks of it as a complex number. The real part is the x value. The imaginary part is the y value. So you could go ahead and write this as 1.03 for the x and negative 1.94 for the y. All right, so that's just a little bit different. Similarly, we have to think about, because you can see our answer is given here as a complex number, when I put in my rectangular coordinates, and here is -15, plus I have to go 3i. I is here where pi is, down in this area. Okay, so when I put this in, it will recognize this as a rectangular number, where 15 is the x-coordinate, and 3, let's see, let's make that -15. And 3 is the y-coordinate. All right, let's change that. Menu, Number, Complex Tools, and this time we're going to convert this to polar. I know, this is very weird. If this were written in the form a plus bi, there we go, you would see that this is the real part, right? This is the real part because it doesn't have the I. So this is that radius right here. This 2.94 part right here, this is going to be the angle. And you can go ahead and take it like this. And it's converted it so they'll be from 0 to 2 pi when I look at this. So again, what I would do is record for my polar coordinate would be something like 15.2 would be the radius, and then this 2.94 would be my angle that I put in there. And this again is in radians. You can see I have a radians up above here.